Today's lesson is about scaled relationships. So, of course, that will have us be comparing different scale copies, the originals and the copies. Okay, so here we are going to select all the statements. Oops. Select all the statements that must be true for any scaled copy of Q, any scaled copy Q of polygon P. Okay, so it looks like we have polygon P is right here. Okay, so the first thing, the side lengths are all whole numbers. Well, it doesn't give us any numbers here for any of the side lengths. So because it doesn't give us any numbers, it could be whole numbers, it might not be whole numbers. So we know that that doesn't have to be true. It could be true, but it's not definitely true. The angle measures are all whole numbers. Well, we know that the angles never change. They're always the same. And since the angles are always the same, regardless of the size of the scale copy, and we look at all these are all whole numbers right here. Even though it doesn't give us this one, we of course know that that's 90 degrees. So therefore, because the original P has all whole numbers for angle measures, B has to as well. So Q, which we're going to make from P, has exactly one right angle. We just went through. This one only has one right angle. C is also true. If the scale factor between P and Q is 1/5, P to Q is 1/5, okay. So that means the scale factor, that means we'd be multiplying by that 1/5. Then each side length of P is multiplied by 1/5. I just said that. To get corresponding side length of Q. Well, I just said it. We know that our scale factor always means that we multiply. So therefore, D is also true. Now, another one. If the scale factor is 2, each angle in P is multiplied by 2. Well, we already know that the angles don't change when we make scale factors. So we know that they don't change, so therefore E cannot be true. And finally, Q has 2 acute angles and 3 obtuse angles. So acute angles, let's not forget, are smaller than 90 degrees. And our obtuse angles are larger than 90 degrees. So our obtuse angles are larger than 90 degrees and smaller than 180 degrees. Okay, so let's see what we have here. We've got, let's look, smaller than 90 degrees. So we've got 1, 2. 2 acute angles. Well, that's a check. Then next we are now looking for the obtuse angles. And those are larger than 90 and smaller than 180. So 1, 2. This one right here does not count. So our F here says that there are 3 obtuse angles, when in reality there's only 2. So therefore, F does not work either. So our answers are B, C, and D. Oops. There we go. And one more time, just for clarity, the answer is B, D, and, oh no, B, C, and D are always true. Okay, next. Here's a quadrilateral. Okay. Well, it's quadrilateral A, B, C, D, to be clear. Okay, quadrilateral PQRS is a scaled copy of ABCD, which of course is right here. Point P corresponds to A, Q to B, R to C, and S to D. If the distance from P to R is 3 units, what is the distance from Q to S? Okay, so I'm just going to draw myself a little sketch. It's going to be a little bit off. We're not real worried about it. I just want to make sure that we're all understanding here. So we said A, point P corresponds to A, so that's P. B is to Q, so this is Q. R is to C, and S is to D. Okay? Then it tells us the distance from P to R is 3. So it means across here, the distance is 3. What is the distance from Q to S? Okay, so we know that from P to R is 3, so that means we have to figure out how far is it from A to C. So if I count that 1, 2, 3, 4, 5, 6, I know that this distance is 6. So if I'm going from 6 to 3, I'm going to take my scale copy and divide it by my original, and that's 3 divided by 6, or 3 6. If I reduce that, it's 1/2. So that means that 1/2 is the scale factor. And remember, that means that I would multiply that by anything else. Okay, so I just found my scale factor, and we now want to figure out what is the distance from Q to S. Okay, so that means in order to find from Q to S that I'm looking at B to D. So I want to count that as 1, 2, 3, 4, 5, 6. Well, 6 is the original times 1/2, which is my scale factor. Put this over 1, and then I keep the top with the top and the bottom with the bottom. So that's 6 over 2. Lastly, you reduce. 6 divided by 2, of course, is 3. So the distance of QS is equal to 3 units. Now, we had gone ahead and found that scale factor, I mean. So if we hadn't done that, we would have noticed that from B to D and A to C are equal. So we know that, one more time, that AC is equal to BD. So we wouldn't have actually had to have known the scale factor, because we then also therefore would have known that PR is equal to QS. Okay, next. Figure 2 is a scaled copy of Figure 1. All right, identify the points in Figure 2 that correspond to the points A and C in Figure 1. Label them P and R. So I would say that A and C are right here. So that would mean that this is P and this is Q. What is the distance between P and R? Well, that would be this distance straight across. So if I did count that, 1, 2, 3, 4, 5, 6, that would be 6 units. Then I need to identify the points in figure 1 correspond to Q and S. Okay, so here's Q and S. Label them B and D in my new figure. So that's B and D. What is the distance between B and D? So that's, of course, this distance right here. I would count that up. 1, 2, 3. That would be 3 units. Okay. What is the scale factor that takes figure 1 to figure 2? So remember, my rule is that I would divide. So let's take a look at this distance from Q to S right here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I take my copy, which is 9. I divide it by my original, how I got to there, which is 3, and that equals 3. So far, I know that the scale factor is 3. But let's double check and make sure, because it is entirely possible that we could be making an error. So we always want to be sure. So the other one that we had was P to R. So let's look at the distance right here. I can see that that's 2. So my original distance P to R is 6 divided by 2 is also equal to 3. And they are the same. Okay. What is the scale factor? Well, that's what I found. So the scale factor is 3. G and H are 2 points in figure 1, but they are not shown. Okay. The distance between G and H is 1. What is the distance between the points on figure 2? Well, because we know that the scale factor, all we need to know is that the scale factor is equal to 3, and we know with a factor we always multiply. So what I'm going to do, of course, is take the 1 that's given, multiply that times 3, so the new distance is 3 units. The last problem, this is just kind of crossing it over between our scale factors, what we're doing in our geometry unit, and bringing it down to like a very simple ratio. So to make one batch of lavender, just so you know, is a form of purple. The ratio of cups of pink to blue paint is 6 to 5. So I always like to have my words first. Words first. Words first. Pink. That was the first one. So remember, I go from right to left, same as I go from top to bottom, just like we read, right? So pink to blue is what I'm comparing. Pink is 6 cups, blue is 5 cups. Find 2 more ratios of pink to blue that are equivalent or equal. So what I'm really dealing with is any scale factor. Any scale factor. So let's just take this down here. And these are only examples. You might have something else. So what if I decided that my scale factor was equal to 10? Well, then I would have 6 times 10 over 5 times 10. That would equal 60 over 50. What if I decided that my scale factor was 2? That would mean I'd have 6 times 2 over 5 times 2, which would equal 12 to 10. I could also decide that my scale factor is 5. And I have 6 times 5 over 5 times 5 equals 30 over 25. You could go on like this all day using any number scale factor that you want. These are just 3 examples. If you're unsure if yours are actually equivalent to the original, certainly you can ask your neighbor that's sitting near you, or most definitely come to see Mrs. De Silva.